All right, good morning, everybody. I'm going to go ahead and get started here. So today we're going to talk about basically residential boiler service. Rob Ellis with FIA. We're the manufacturer's rep for Lochinvar. And my role with FIA is in technical services. And we're going to change up just a little bit today. What we're going to do is going to start off with just a conversation about the two different styles of heat exchangers that we see residentially. That's going to be the water tube and the fire tube. And then actually, I'm kind of going to cut down into our basement boiler room where I've stolen my son away from doing his classwork this morning, and he's going to kind of run us through a combustion analysis on the boiler briefly, and then we'll come back here and we're going to talk a little bit more about the boiler itself. So go ahead and kind of get started here. I want to jump over just to give you a good view here on this one here. So just taking a look right here, this is the a water tube style heat exchanger. And as you kind of look into it there, what you see is the fact that the tubes on the heat exchanger kind of create for a different sort of experience as far as cleaning that is involved. And so what it does on that one there, and I know that bandwidth is a little bit low, so it's a little bit behind. And what that's doing is in those, you got to clean in between those tubes as you're going and cleaning through that one. So it's making sure that we don't have any buildup inside the tubes of that heat exchanger. And that one's really important. Now, as we move back over to the fire tube style, right here. So this is your fire tube style. It's a little bit different. We're going to fire down through the combustion chamber there. So as we clean through in this one here, we're just kind of cleaning it up with a little bit of vinegar and water solution. And then we're going to clean it with a green scrubby. And then we're going to kind of rinse down through as we do that one. So this is a little bit easier to clean on this style here of this heat exchanger. And that's how this one's going to work a little bit differently there. So this one here, we're just kind of going to spray it with some vinegar and water solution, and then we're going to green scrubby and wash down through there. And when we're over in the water tube style unit, in that one, we're doing more of a cleaning in between those tubes and cleaning in the waterways, still vinegar and water, and we're using just a nylon bristled brush, if you will, to clean down through that one. So let's go make sure that Shiloh is ready down in the boiler room. Shiloh, you ready to go down there? Maybe not quite yet. You good down there?
I think I am. Are you able to hear me?
Yep, we can hear you.
Yeah.
All right, you want to show us how you put that thing into service mode
Sorry,
and off you go?
technical difficulty. All right, so right now I'm downstairs. Yep. All right, so basically what you do is you have your usual display board on most of the boilers. Right now we have a night boiler, and it's probably hard for you guys to see, but there's a button that says reset, and about half an inch under it is this. It's kind of like a little abyss that's able to fit a paper clip in. And so to put the boiler in service mode, you put the paper clip into the little abyss, and you want to make sure that's head on. And you will press a button that's inside there for about 5 seconds, and then this fan will start going, and that's when you take it out. And so you take out your flute, take out this that's right kind of launched in, and then you put your analyzer tube right where that was, and then you wait for this whole thing to get ready. There'll be a flame, and then that's where you set up your testo and you press basically go, and that tracks what the boiler is actually doing. So right now the numbers on here are going up, and in a little bit they'll start to stabilize. And the one that we'll be looking at right now is in the third spot, which is the parts per million CO. And that, so right now it's at 31, and it looks like it's stabilizing around there. So now it's starting to go up one by one. It's at 33. And then once that stabilizes, so right now it's stabilizing at around 35 parts per million. And then you're just gonna put your paper clip back into that hole that we found, and then just do one tap and on that button that's down there, and the fan will start to go down, start to turn off. And if you press, there's this button that says end, and that takes out the service mode.
Oh, thanks so much. All right, so a little sketchy on the internet down there. The kids in the neighborhood are all playing Minecraft this morning. So let's see if we can, so we're gonna switch over to the front camera here. It's got a little better internet connection. So let's talk a little bit about the gas train and how those things go and what kind of goes through how this boiler works. So combustion-wise on the boiler, we're looking at a negative regulation combustion system. And basically that negative regulation combustion system is the fact that, switch this one off here, try to clean up our internet just a little bit here. All right. So as we're looking at the, negative regulation combustion system, what we have in that case is a fan drawing air across a venturi. As it moves across that venturi, and here's a complete assembly for a 5-to-1 turn down. This is actually off this water tube style boiler. Is this fan draws the air through this venturi. The venturi pulls the gas through. As we mix down in here, we're going to push it down through the air arm. That air arm is going to put that through the burner. We're going to spark, and then we're going to test and sense the flame right here. So how does that all kind of work? How does that venturi work? Well, right now, residentially out there in the field, there's two styles of the venturi. There is basically the older 5-to-1 style venturi, and that's this assembly, which mounts on the side of the Honeywell gas valve. Now I was able to kind of get it apart this morning, which makes it a little easier to see. This is the insert that is inside of this venturi here, and that helps to really explain how it works. And the venturi itself is a couple of pieces. So on the end, I've got this end cap. When that cap fits on, it actually creates an opening right in here. That's the orifice. So as the air moves across there and draws through, it creates suction on the outside here. And that suction translates through into here. And this is where that really adjustment point is. So this all inserts in here. And as I pull the gas in, the gas is going to come in here, inside on the outer part of that center orifice, and then actually gets dumped in, where it kind of creates a mixture, if you will, gas-air mixture in there. And then it's going to push it through. It's going to take it into our fan and into our burner. So just thought it was kind of a nice way to take a look at it. And this right here is that adjustment. This is that kind of the main adjustment of that gas valve, if you will. We're adjusting the gas-air mixture. As we tighten this down along here, that's going to change how much gas we're pulling and mixing in with there. And for those of you that are familiar with it, that brass screw that you see is actually right here inside of this this venturi, is where that goes. Now, the current model uses a 10-to-1 turn down, and it uses a different venturi. So here's the venturi this one here is. Now a little different is the new venturi, the 10-to-1 style, mounts to the fan. The older style venturi actually mounts to the gas valve. So if I take this one apart, this is my center section of it. I actually have two orifices. One's top and one's bottom on there. And so what these are doing, exactly the same concept. As the air moves through the venturi, creates negative pressure on the orifice. That suction is pulling the gas in through this opening on the outer side of the inner venturi, if you will, and the orifices, down into here, into the fan, down into our burner. We get our combustion. So that's kind of just a quick thing of how that negative regulation works on that end of it. There's a couple of more things that we have sort of in that come into play in there. One of those is on our air intake. We have this brass fitting. Now that brass fitting connects actually on to whichever gas valve that you have, and it's actually adjusting the gas valve itself, kind of adjusting that flow. So it's kind of a unique feature in the fact of, because this pipes directly to the outside, as your atmospheric conditions change, this is actually going to adjust that gas valve for you, depending on, you know, density of the air. So in a warm, dry day, it's going to be different than on a you know, kind of a cold, wet day, or even a hot, wet, moist day. It's all going to change, and that's going to be making those adjustments to it. Now we'll kind of circle back to that air and how that's working here in just a little bit, but I want to talk about some more stuff that's here. We've talked about the differences in the gas train, where they're very similar and yet a little bit different, but it's negative regulation. We're using the orifices and the venturis on both to kind of create that combustion. But let's take a look at our burners. Now, I have a burner right here. This is from a WHKH. This is the fire tube design. This burner here is a KBN water tube design. So very, very similar, with an Alcromesh coating on them on the outside of that stainless steel burner tube. And the way that the combustion kind of works on these is, as I bring that gas air mixture in through them, same here, and I bring it out of my burner and I spark it here, my combustion is not particularly on that burner. It's almost off that burner, and it's kind of a glow, if you will. It's not a flame. You know, we refer to it as a flame. We talk about it as a flame pattern, but it really is more of just a glow that you'll see there at low fire, an orange glow. As I ramp up, I'm going to get some blue in there, and I'm going to see some orange specks is what's going to happen within there. So it's really important to see that, and a consistent flame pattern all around. We don't want to see a big blue flame. We don't want a big ball of flame, stuff like that. So just important to know that that's what it's going to look like. There's a third burner style that we'll see residentially. Just want to get that one out there for you. This is the Noble. Okay, we're not really talking about the Noble today, but the gas train for the Noble, the WH, and the KBN are actually the same style fuel. I'm sorry, KBN and WH there. This is more of a flatter, rounder design on this one, so just a little bit different in there. Regardless of the burner, regardless of the gas valve, the combustion system is really the same across the line as you're working through these things. So a couple of things that are just important to understand is, on all of them, I'm going to use a spark electrode with a built-in flame sensor. On KBNs, WH, and KHBs, I have a secondary flame sensor. On a Noble, I don't. But what it does is, I'm going to spark and light. I'm going to sense flame here, and I do use this as a backup flame sensor. But an ignition cycle is something like this. I've got a 5-second trial for ignition, which is generally about 4 seconds of sparking. Within that 5th second, I prove flame. Once I do that, I'm going to go off into my my modulation factor of the boiler. So it's pretty simple. Cleaning the burners, they all clean the same. They all clean with compressed air. That's it. There's no water, there's no brushing, there's no vacuuming, there's nothing. It's just compressed air. That's all we're going to do to clean these. And so once you get it, and it's taking your time, but I'm going to go back and forth with that compressed air. I like to go at it at about a 45-degree angle, so I can kind of push through and go out there. Is what I'm going to do. Sometimes you might have to vacuum some stuff out, especially if you have an air intake by a light. You're going to look for things like gnats, black flies, whatever you got being sucked in here, moths. those sort of things. But generally, clean the outside of those. We walk through that is more of the ignition system. That's my ignition module there that I've got going on right there. So let's walk through one that's not lighting off and what we should be looking for. So we're looking at one that doesn't light off. What we want to look at is kind of whether these things might not be working. So let's just start with, I'm going to pretend we're using a KH here. So line my stuff up. So what we want to do is make sure we got the triangle of combustion there, air, fuel, spark. So generally my recommendation is if I've got a boiler that's not firing, I want to put my, sorry about that. I want to put my test hose on the inlet side of that gas valve. Now, why the inlet side? The inlet side is positive pressure. The outlet side is negative pressure because we're creating a negative and pulling the gas through there. So when I'm on the positive side of it here, I'm going to connect my hose to my manometer. Now I want to cycle my boiler through. So what I'm looking for is, do I have gas volume? Do I have gas pressure? And does my gas valve open? So how do I tell that? Once I put my manometer on there, really the first thing that I'm going to do is get what is my static pressure? And that is the gas pressure with the gas valve closed and the boiler off. So what I'm looking for there is somewhere between 4 and 14 inches. So let's just, for this example, say we have 8 inches of gas. Now, if we've got 8 inches of gas, and now we're going to set it into, we're going to trial for ignition. We want to see that gas valve open. We want to see a drop in gas pressure, maybe an inch, maybe 2 inches. So if my 8 inches were to drop down to 6 inches, that would tell me I had good gas pressure and I have adequate gas volume. Now, if my gas pressure goes from 8 inches to like 2 inches, I have good gas pressure, but I don't have enough volume for the size of my boiler, is really what's happening there. So at that point in time, we want to stop. We want to track that down, see what's going on. Do I have a problem with my meter, with my regulator, my gas pipe sizing, all of those things? And there are definitely some ways to kind of eliminate some things. You got a boiler that's been in a couple of years, gas pressure's never been a problem, and all of a sudden you got a 6-inch drop in gas pressure. Hey, let's go out to that meter kind of quickly and just see, do I have a meter hanging up? It's a good cause of that sometimes. If on my manometer, I go from 8 inches and I stay at 8 inches, there's a pretty good chance my gas valve didn't open. How do we troubleshoot that? Well, on a call for heat, our control board sends 24 volts out here to our gas valve. So we want to make sure that we're receiving it here. Now, one of the things to be careful of is these got a pretty small set of pins in there. And a lot of times people take that Molex plug out. We're going to insert our multimeter, probes into those pins. We really want to avoid that and try and take it from the outside of the Molex reaching in. Otherwise, you can stretch out those pins. And maybe this wasn't your issue, but in troubleshooting, you then damaged the Molex plug connector. So make sure you're not, stretching out those pins. So it's a blue switch on that one. We get into the older style and it's a red switch right there. If you think it's not opening, put your hand on it. You'll feel the solenoid activate when it's getting its 24 volts. Now, the other point of keeping this plugged in as opposed to taking it off is sometimes you take it off, you really kind of take some of the load off, and it may work when it's not connected, but keeping it connected is definitely where we want to check for that 24 volts, see if something's dropping out. So keep that on. So if I've walked through this, I got 8 inches of gas, my gas valve opens, I got a decent drop. Let's move to the next thing in line. Next thing in line I like to check is the spark, okay? So I want to check on the spark is, here's your spark electrode, basically connected to the cable. There is a ground wire that'll go on here. If you can't tell if it's sparking, take it out of the cabinet and just let it hang outside of there. Leave the ground connected. The reason you need the ground is, for it to spark, I'm going to send that voltage out this direction, and it's going to actually come right back to the ground. If I disconnect that, the spark can't make its way back. So make sure you keep that connected. If I don't spark here, really step 2, take the spark electrode off, take your cable, and hold your cable over near one of the studs on the heat exchanger. Now don't put it on there, but just hold it off, let it spark across that distance, that spacing there, and see it spark on there. If I spark here, I'm gonna wanna look at this. If I don't spark here now, I'm gonna go back to my main control board, and I'm going to look at that ignition module, and I'm gonna disconnect from the ignition module, and I should see a spark from here to here. If I spark here to here, I didn't come out the end of my cable, I didn't come out the end of my igniter. Those are the 2 things I'm gonna troubleshoot. If I don't spark here, I'm gonna replace that. It's got that ignition module on it. Now, one of the things that we check if we're not coming out of the igniter, we're not coming out of the cable, there's a resistor in here. We want 1,000 ohms in that resistor. So go ahead and do that with your multimeter. You set it to that goofy looking horseshoe thing, set it on here. We're looking for that 1,000 ohms. What that resistor is within the boiler, the control panel, there's some communication between the fan and the control where we're kind of using this pulse width modulation signal. And we send the signal out and the signal's got to come back. So it's kind of a boiler telling the fan, I want you to do this, the fan coming back and saying, here's what I'm doing. And that signal can get interfered with, and that's why there's a resistor in there to kind of prevent that from happening. So just check and make sure you have that. A bad ignition cable, what that really can lead to is some intermittent flame failure ignitions type of scenario where sometimes it lights, sometimes it doesn't. It's just messing with that signal there and that connectivity. So that walks you through there. If I had gas and I've got spark, where's my next? Where am I looking for next? Well, now I want to go to the air side. So a couple of things to look for on the air side is, do I have an obstruction? Do I have something like that? Hitting the bottle really early on the Monday morning. Let me tell you, it's a long week of Zoom. You don't even know what day it is anymore most of the time. So the air is important for a couple of things. If I reduce, go back to this guy here. If I reduce the amount of air I'm pulling here, reduces the amount of air that's going here, reduces the amount of air going across my orifice. Make sense? If I reduce the air across the orifice, I change the air that I'm basically pulling out of my gas valve, okay? So what can impact my airflow? About a dirty burner. So if I'm pushing through here and I plug this all up, I'm reducing the ability of my fan. It's an ECM fan. If you're familiar with ECM, it's going to back up. That's all it's going to do. Now, it might be trying to go at 100% and doing its thing, but there's so much restriction on it. So if that begins to happen, my airflow drops off, my flow through my venturi changes the gas that I'm pulling. Now, I want to stop like right here because it's an important part. So we got a little bit of combustion analysis downstairs, but the kind of the important thing is a lot of times people will go out, oh, my combustion's off, I'm going to put my analyzer on and I'm going to adjust my gas valve. But this is the problem. If this is dirty and you adjust your gas valve for a dirty burner, eventually when you clean the burner, your gas valve is going to be out of adjustment. So just some important things to kind of consider there as you're working through those sort of things. We never want to do a combustion. We can do a combustion analysis. Never want to adjust the gas valve if we have not cleaned the burner. So clean your burner if you have to. So if you think I got spark, I've got fuel, where am I going next? If I got a boiler that's 3, 4, 5 years old, and I say to the customer, hey, when did you clean it? Next or last, I should say. And they go, oh, 4 years ago, 5 years ago, I've never cleaned it. Let's do a service first. Let's clean it. And how do we get there and how do we do that? Which is pretty timely as Nick just asked that question. So let's spin this guy around. All the burners really come out, I should say, come apart in the same fashion. Um, Generally, the first thing that you're going to do is disconnect the gas valve from the fan. Now that works in two different ways. When I have the older 5-to-1 style, what I'm doing is I am disconnecting right here. I'm going to take this off the fan. As I get into the newer 10-to-1 style, I basically right here, I've got a G-nut on that, if you will, connected here. I take that off. Now at that point in time, my fan and my gas valve are disconnected. And I'm going to move to remove my fan and burner plate assembly. So in this case here, I still have the gas valve on it, just more as a demonstration purposes. So I would take this off. I'm going to disconnect my gas train from my fan. Now as I'm looking at the front of it, matches up to here. It's 10mm nuts on these studs, and it's the same on fire tube or water tube, 10mm. I'm going to take them off. Now loosen them all first and do it in a star pattern. What can happen is, let's say I put this boiler together and I didn't do a good job of putting a backer on my gas pipe coming in, and I put some torsion on it. As I'm taking these studs off, if I'm left with maybe this one here and I haven't loosened it, I'm going to put all the pressure on that one. So loosen them all up first, do it in that star pattern, then take them off. And then once you do, you're going to disconnect this from the front. Now, Nick's kind of asking about the, how these come apart. And what I'm doing here is, when I'm in this style, this KBN water tube, and I want to get my burner out, I actually disconnect the plate here, okay? Not taking this front piece off, but I'm going to disconnect the plate there. This piece actually kind of sandwiches the burner in the middle. So I take that off and I'm going to pull the burner out. Now, real important, don't take this off while this burner assembly, this front door is still connected. If you take that off, now this is a short one, but when you're into some of the longer ones and you've got maybe a 24-inch burner, the weight of that burner will drop down and basically will crack the refractory, which is the same as this, that's on the inside. So take it all out, set it down where you can work on it, take it apart, remove your burner. Now, when I'm in this style here, what I'm going to do on this one will be to remove my igniter and flame sensor. My refractory is going to lift up. And at that point in time, I'm going to be at my burner bolts. Take your burner bolts, pull the burner off, do that. Now in this model, when I'm in a fire tube style, I will need to replace the burner gasket. When I'm in that style, there actually isn't generally a burner gasket that I'm replacing on that. It kind of tucks in the other way, a little bit different design on those. But on this one, I'm always going to replace that burner gasket if I take it apart. Now, if I've taken the door off while we're on gaskets, when I'm in this style, what you see here is a rope gasket. Now that's not a replaceable piece. You replace the entire door. It's a pretty infrequent flyer on this one. We may on occasion see this gasket, but this gasket's really in a kind of a cool spot, if you will. When I'm in the fire tube designed units, we have two styles of gaskets in there. So the newer style uses this red rubber gasket. Now this is generally reusable when you take it off. What's the exception to that rule? Maybe I've had one of these that's been in 4 or 5 years and I've never opened it. I might have a hard time taking that gasket apart without damaging it. But if you're pulling apart every couple of years, you'll get some reuse out of this one. Now, if you're in the 5-to-1 style, that gasket is a little different design. That's a fiber gasket. And that's this one right here, okay? And This one you're probably going to have to replace every time you take it apart. When you do that, and I know that Ray just put on there that the rope gaskets come in the tune-up kits. They don't anymore. They're no longer selling those separately. That's from the heat exchanger manufacturer themselves. So you have to buy a whole door if you need a new rope gasket. I still have the original rope gasket that I got with my tune-up kit 12 years ago. Haven't had to use it anywhere yet. Don't see a lot of those getting used. So that's the gasketing on those. Nick, hopefully that answers how to get that burner out of there when you're going to do that on your question there. Let's see. So a PM. I'm going to replace the igniter and flame sensor. I'm going to replace my gaskets potential on the older style fire tube. I'm going to have to put a new gasket on there. A lot of times I'll leave the burner on, I'm sorry, the fan on top. That prevents you from replacing this fan gasket. But if you take the fan off, you will need to replace the fan gasket. So pretty good idea to have with you heat exchanger door gasket, fan gasket, an igniter and flame sensor with you if you're going out to do a PM on one of these. Talk a little bit about the refractory here. When you first go to kind of pull one of these out, this refractory may stick in the top of the heat exchanger. If it does, take your igniter and flame sensor out first, and that way you can leave this down in the top of the heat exchanger and pull the rest of it out, okay? And free it out. Just so if you try to yank it and twist it, you could damage it. If you damage this, you will need to replace it because that's really the protection for this top cover. This one here has one as well. It would normally be right here to protect this door. All right. So while you're there doing your PM, and we really went from how did a service call lead to a PM, but that's that air side dirty burner, dirty heat exchanger. So while you're doing your PM, one of the things we want to take a look at is our cycles of our boiler. So that's going to be how many hours it runs versus how many ignition attempts. Then we want to do a little bit of math. So basically kind of divide the run hours with the ignition attempts and let's see what we get. Generally, if I'm into this style here, no more than 6 to 10 cycles per hour of runtime, okay? When I'm on the fire tube style, really no more than 6 cycles per hour of runtime. And that, what we want to do is let the boilers run, let them be able to run clean, if you will, you know, not short cycle on and off. We want them to be efficient. We don't want to also, we don't want to short cycle on those and, you know, could do damage to parts and that sort of thing. So that's what we want to do. Question about the temperatures that these gaskets can see. So on the fire tube, those gaskets are really in the water backed side of it. So when we're in there, we're protected by here. Really what we're seeing is the water temperature side of there generally. That's what we're going to do. Because that gasket is up here, it's kind of protected by this sort of thing. So basically that's what we're going to see, the water temperatures kind of into our gaskets there on that side. So we've done our PM, we've cleaned it, we put it back together, we're checking our cycles, and we find out that our cycles are too much. What do? We want to take a look at our ramp delay settings, and we want to take a look at our outdoor reset settings. We want to try and slow our boiler down, and we can do that a couple of ways. One is lower our water temperatures. The lower the water temperatures, the more the boiler is going to run to handle the space heating load as opposed to kind of over firing or over driving. And then ramp delay is us telling the boiler to physically slow down. Now, next week, this is how we lure you back in, right? So next week, we're going to do the smart control. And when this comes out, you have a link to come into that one, because we spend about 45 minutes just on the control and enabling that ramp delay feature and making sure that we're getting, you know, the most we can out of our boiler as far as efficiency. So we're going to set those. We button it all back together. We want to pressure test everything. So we want to bubble test it. So if we're putting this one back together, you put my bubbles on it, and at that point in time, my fan has 2 connections on it. This guy was hiding on me down there. I got 2 connections. I got a 3-wire and a 4-wire. The 3-wire is power. So as long as this connected and my boiler is powered up, when I disconnect this 4-wire, my fan is going to run to 100%. It's going to run to its maximum speed. When I do that, I'm going to pressurize inside this heat exchanger, and I'll be able to bubble test it without it getting hot. If I light it first, this is going to get hot maybe sometimes before I could see everything on my with my bubble test. Same on doing the top plate here. So set that. We want to bubble test anywhere we took apart. All of our gas fittings, those sort of things. On here, we'd be looking around the various studs on the heat exchanger top and around our fan. So, and go through and, you know, just take a look at all of those. So circling back on this one, I didn't get a lot of time. For some reason, we're having internet connection issues today. Normally, it's been pretty good for me, but today, not so much. And that is getting in here and cleaning this in between these tubes. What we don't want to have is buildup in the tubes. The design of this heat exchanger is that my air movement is in between these tubes. As I do it, you know, that goes through there. This wall here is not all the way at the back. So as I go out through those tubes, I'm on the inside this outer wall, if you will. There's a space, there's a cavity for that. And as you can see, that wall that we're looking at allows the air to kind of move down here on the back through tubes, through another set of tubes, and then goes out through there. So that's how we're getting all the energy out of there. Okay. So we want to make sure that we get clean in between these tubes so that we can get good air movement. And as I say, the nylon wheel does a good job with that. You could actually use like so much a credit card, but if you have like those old hotel key cards, you know, they're nice and smooth. You punch them down in there through that, those sort of things. If you have one that's really dirty, I'd start with vacuum it out first. Then I want to hit it with that wire wheel, that nylon wire wheel through there. And then I'm going to hit it with my vinegar and water solution, wipe it out, flush it down. Now, right now, for simplicity, this one's upside down. Flush it down. It's going to come out through here into my condensate. A couple of creative guys that I've seen have taken and put a, you know, barb by hose adapter. So they disconnect this off. You put a barb by hose adapter, you're able to put it onto a hose and flush it right out of the boiler, not through the condensate trap. You do flush through the condensate trap, make sure you're taking that trap off and cleaning it when you before you put the boiler back in service. The 5-to-1 style, the Giannone style, had an actual kind of cylinder trap in there, whereas the new fire tube AIC just has a little trap on the bottom, and you can pull that trap right off and clean it out nice and easy. There. We have any questions at all? Anybody? If you want to, I've muted everybody, but if you want to go ahead and